There are currently 5 objects exiting our solar system, but where are they going next, and what will be their final destination? Hi everyone, Voyager here, and in today's video we're going to be looking at Pioneer, Voyager and New Horizons and their final destinations. So, let's get to it. Pioneer 10 was the first probe to traverse the asteroid belt and later to reach the giant planet of Jupiter after its launch in March of 1972. Its sister, Pioneer 11, became the first probe to reach Saturn in September of 1979, with both probes setting the scenes and proving the routes for later Voyager. Voyager 1, of course, was launched in 1977 and also reached Jupiter and Saturn, but more importantly this time, arrived at the Saturnian moon of Titan. And Voyager 2, perhaps the most famous of all, launched slightly before, interestingly, Voyager 1, reached both giant gas worlds, but later the ice giants of Uranus and Neptune in 1986 and 1989 respectively. And finally, after a huge gap of almost 25 years, New Horizons finally reached, first of all, a gravitational flyby, the giant planet of Jupiter, and later the beauty of Pluto. So, where are they now, you might be asking? Well, imagine we could see them in a horse race. In this graphic we can see the relative speeds approximately correct. Remember, of course, that Pioneer, when it reached Saturn, Voyager had already reached the giant planet of Jupiter, and as we can see here, is now further ahead than any of the other probes. Voyager 1, at 152 astronomical units approximately, is the furthest man-made thing that we've ever created. New Horizons, obviously dragging behind, will eventually reach up to the Pioneer probes, but the Voyager probes are long gone and will never ever be caught by any of the other remaining probes. So let's look individually at where each probe is going. Here we see Pioneer 10 travelling at some 2.52 astronomical units a year in the direction of the constellation of Taurus. Its first next destination will be the small star of HIP 117795 in some 90,000 years from now, where it will approach 0.75 light years. HIP, the star, is a K-type star with some 0.33 solar radii and will appear at magnitude minus 0.39 from the Pioneer 10 probe, so a bright star but not the brightest in the sky by any means. Pioneer 10 then jets off towards the huge red giant star of Aldebaran, also known of course as Alpha Tauri. For a long time in the Pioneer 10 skies, Aldebaran will become the brightest star, although once it reaches the approximate position of Aldebaran now, the star itself will have moved on. Radio comms were lost to Pioneer 10 in 2003 at just 18 astronomical units. Imagine if it could still signal from the star of Aldebaran, and imagine the weakness of the signal by then. It would be astronomically small. Pioneer 11 is moving slightly slower than its sister probe at 2.37 astronomical units per year towards the Shield constellation of Scotum. Its first encounter will be a very small star known as TYC 9921921, what a great name, in some 928,000 years. An approach will be around 0.81 light years. After that, it's unsure of exactly where Pioneer 11 will end up, but perhaps the most interesting star that it is heading roughly towards will be Delta Scuti in millions of years from now, and its approach will be around 2.6 light years from the star itself. Delta Scuti is an F-class star, a bit like Vega, that's currently 202 light years from the Sun, but moving towards us, a variable star that pulsates. At that approximate distance, Delta Scuti will appear at magnitude minus 4.772, roughly the same brightness of Venus in our own skies, and will remain the brightest star in Pioneer 11's sky for some time. Pioneer 11 actually shut down in 1995, somewhat earlier than its sister probe. Its signal became just too faint to hear in 2002. As both Pioneer probes slowly exit our beautiful solar system, which here we can see in a slow time-lapse, we must remember their achievements. Pioneer paved the way for Voyager probes to explore places like Titan, because it explored the hazards of the Jupiter radiation belts and the asteroid belt. At the time we weren't sure just how full of asteroids it was. In fact, the nearest asteroid that Pioneer passed was 8.8 million kilometers away, or 5.5 million miles. Its largest hit in the end was only a small fragment of 1 millimeter wide. The Jupiter encounter produced 500 images and an Emmy Award for the presentation, and was the first slingshot maneuver ever made by a space probe. Without Pioneer, we would never have been able to visit Uranus and Neptune, as Pioneer 11 was used as a test to go through the rings of Saturn and see if it was possible, and later the Voyager probes would follow the same route. What a magnificent achievement the Pioneer missions were, and certainly will go down in history as one of the greatest achievements of mankind. So let's move on now to the Voyager probes. Voyager 1 is travelling substantially faster than its Pioneer relatives at some 16.9 km a second. Its direction is the tongue-twisting constellation of Camelopardalis. Its next destination, of course, having crossed the heliopause back in 2012, will be the Oort cloud, in which it will take some 30,000 years to traverse. After that, an M-class red dwarf, current distance of 17.1 light-years, Gliese 445 has 0.14 masses of the Sun and is a tiny star. Even at the distance of 1.6 light-years, it will only shine at magnitude 3 in Voyager 1's skies, and the Sun will remain the brightest star in the sky for some time. After that, the even smaller star of TYC 3135521, yes, I said that right, in some 300,000 years. Its approach will be even closer at less than 1 light-year, but again, because it's such a small star, the magnitude will only be in the region of 2, so it would be visible to the naked eye from Voyager 1, but won't be a very bright star in the sky at all. Voyager 1 last tested its thrusters in 2017 for the first time since 1980, but is now heading off into the distance, into the blackness, with only a few red dwarf companions to keep it company. In our next graphic we can see the beautiful view from Earth of the Voyager 1 timeline, 1978 Jupiter, 1979 Saturn, before it made an encounter with Titan and skewed it away from the planetary plane, as we can see heading roughly in the direction of the star of Arcturus. Voyager 1 indeed could have actually carried on towards Pluto, but it was deemed more important to view the Titan atmosphere, and they were probably right, otherwise we may not have got New Horizons later on. In one of its final acts, the Voyager 1 probe was once again turned around to face the Sun and our solar system in the family portrait, the now world-famous picture in which we can see our own little blue dot of planet Earth alongside all the other beautiful planets of our solar system. What a wonderful picture this was, and what an achievement for humanity. Voyager 2, in contrast to Voyager 1, was moving slightly slower at 3.21 astronomical units per year, towards the constellation of Telescopium. Its next destination is the small star of Ross 248, also known as HH Andromedae, that currently is a distance of 10.3 light-years from the Sun. In 42,000 years, Voyager 2 will pass by a 1.7 light-years distance, but Ross 248 will only be magnitude 5.45. Voyager 2 will barely be able to recognise it. What a disappointment that will be. But wait, let's see, because later on, in 296,000 years, it will approach the huge star of Sirius, one of the giants of our local area, towards a distance of 4.3 light-years, still quite a long way, but Sirius at that point will be minus 3.182 in the skies, almost as bright as the planet Venus, and a wonder, and will certainly light Voyager's 2 skies up for some time. The A-class star of Sirius, one of my favourite stars, will surely be a wonder to see from the Voyager 2 probe, if only we could join it on its journey. The final of our probes, of course, is New Horizons, the third fastest of the 5 at 2.66 astronomical units per year. Its direction is the constellation of Sagittarius. New Horizons, of course, the first to visit to Pluto, will reach 100 astronomical units in the year 2038. We hope that by then it will still be receiving signals. After that it's unsure, as New Horizons does contain 11 kilograms left of fuel. It could be directed towards a further Kuiper Belt object to replicate its encounter with Ultima Thule, now renamed Arrokoth, which was a wonder to behold. Eventually, New Horizons, like its other forebearers, will leave the solar system completely. Possible destinations might be Alpha Sagittarii, also known as Rukbat, a star some 182 light-years from here. It's a B-class dwarf. It has 117 solar luminosities and is an extremely hot star. Its 2.49 solar radii mean that it's quite bright, even though it's a small blue-class dwarf. The wonders of our solar system have been explored by these 5 probes: Pioneer 10 and 11, Voyager 1 and 2, and finally New Horizons. It's my hope that one day we'll conquer spacecraft propulsion to the extent that we may just be able to send a spacecraft out to these distant objects and reclaim them as our own and put them in a museum. Here in this graphic we can see that happening with the sun twinkling in the distance. Let's hope that in the future the deep realms of space will be explored by further probes, and even one day maybe humanity itself. Thanks for watching. I hope you've enjoyed the video. Please don't forget to add a like if you have, it does help the channel grow. If you've enjoyed this video, you might try other videos that we have. Perhaps you might like a journey to the star of Canopus, or perhaps you might find Hellas Planitia, Mars' deepest place, interesting. Or perhaps even you're more interested in stars, and what a star to choose would be R136A1, the most powerful star that we know of. Anyway, in these difficult times, stay safe, and I'll see you on the next one.